when will we ever learn? Well, I think we should start now if we haven't started already. Very, very important. And I do commend to you, I didn't want to wear a wig or a frock to do this presentation, because this was actually going to be Gillian Carson Jackson's paper, but I do commend her paper to you. It's a very good paper, written by Michael Squires as well. It covers a lot of good material and a few statistics as well. Thank you very much, ladies and gentlemen.
I hope you are formulating your questions as we go along. Don't forget you have the opportunity to fill in a question sheet or wait for a microphone to come to you in the final part of the session. So our next speaker, Peter Douglas, Navigation Manager with Northern Lighthouse Board in Scotland. Peter joined the Royal Navy from university and specialised in weapon engineering, including operation of air surveillance, target indication, navigation and control, fire control radars. He's been with Northern Lights since 1993 and has a master's degree in navigation technology and is a fellow of the Royal Institute of Navigation, and he chairs the technical working group of the IALA E-Navigation Committee. He's going to talk to us about enhanced radar conspicuity of small craft. Peter.
Thank you, Mr. Chairman. I was on the phone to my son last night, my young son, and he was telling me that he'd had to do a presentation in school yesterday. And I said, well, that's a coincidence because I've got to do a presentation to the class tomorrow. He said, how many people? And I said, well, about 400. He said, wow, it's a lot bigger than my class. Enhanced radar conspicuity of small craft, particularly in fog and clutter conditions, is a subject of long-standing personal interest, based from seeing this issue from both sides, from the bridge of a destroyer, watching as a small wooden yacht went down the side of the ship, and wondering where that had come from, and why we hadn't picked it up earlier. And also from the deck of a yacht, watching the large ship on a steady bearing, and wondering whether they've seen me, whether they plan to do anything about that, and whether I have any options to avoid them. What I plan to do this morning is introduce the problem, take you through a few case histories, suggest some possible solutions to the question of poor radar conspicuity, and then look briefly at alternative collision avoidance technologies, collision mitigation issues, and finally touch on future radar developments. We all know radar is fitted to surface vessels and is the primary technology used to avoid collisions at sea. We also know that most small craft are constructed from wood or glass reinforced plastic, neither of which are very good reflectors, and both of which produce a very poor radar return. We can measure the radar conspicuity of various vessels from different azimuths and express this as the equivalent value for a reflective sphere. So you can have a relatively small radar reflector, 8-inch radar reflector, and it's expressed as perhaps 20 meters squared radar cross-section. There is quite a lot of similarities between visual and radar conspicuity, but we know that radar is attenuated, particularly in rain conditions. It can be enhanced by diffraction, but it suffers from a particular problem which is multipath, in which the reflection off the sea surface can interfere with the direct reflection of the contact. And sometimes this can be positive interference, increasing the size of the target. Sometimes it can be negative, cancelling the target out. I've got a few case studies this morning. The first one, which received a lot of publicity in the UK, was a yacht called the Ouzo. Ouzo was run down at night in August 2006, almost certainly by the 37,000-ton ferry Pride of Bilbao. It is fairly clear that the yacht was not seen on the ferry's radar. It's unclear as to whether the yacht had actually fitted a radar reflector at the time. The remains of the yacht were never found. It is believed that a gradual turn on the part of the ferry, having not seen the yacht, limited the potential reaction time on the yacht and resulted in a very close quarters situation, which swamped the yacht. The 3 crew on board the yacht survived the incident in terms of going into the water with life jackets on, but as no alarm had been given, they all died from hypothermia. As I said, the USO received a lot of press coverage. There was an MAIB investigation, a Marine Accident Investigation Branch investigation into the USO. It looked at ferry watchkeeping standards. The manning of the ferry was much better than a lot of vessels that we see. However, both the dedicated lookout and the officer of the watch at the time had severely degraded their night vision previously by the use of white lights. And that may have been a contributory factor. There were questions regarding how effective a yacht masthead light is, particularly with the type of plastic that used ages and becomes opaque over a period of time. But the biggest concern in a lot of quarters was why the yacht had not been visible on radar. And this generated a further technical study looking at the types of radar reflector that are available on the market. I'll come back to that later. From the opposite side of the world, another case study, a fishing vessel called the Alenia ran into the side of a container vessel of Australia. The cause of the accident was definitely down to a poor lookout on the part of both vessels, but the Transportation Safety Report commented that intermittent or weak radar echo in the sea clutter and rain from the wooden boat was a contributory factor. There are plenty more case studies. These are all from British waters. Coincidentally, the Pride of Bilbao, the same ferry involved in the USO, had near missed another yacht a few years earlier. Another yacht, the Tula, disappeared in the North Sea, almost certainly as a result of collision in foggy conditions with an unknown vessel. The yacht on the bottom left there, the Wakuna, was run down by the container vessel Ned Lloyd Vespucci in thick fog in the channel. And another vessel, the yacht Whisper, was run down by Gas Monarch in the North Sea. There were common themes to most of these incidents. It's very apparent that small craft lack visual and radar conspicuity. It's also apparent that there is an over-reliance on ARPA radar to avoid collision. It's clear that incidents between large, fast ships and slow, small craft become critical over a very short time scale. A ship that's 3 miles away doesn't look like much of a threat, but if he's doing 24 knots, in 7.5 minutes' time, he's going to be where you are. The rule of the road, the international rules, Rule 6 about safe speed. I think that it can be said that that is sometimes observed more in theory than in practice. And even when fitted, passive radar reflectors are of limited benefit and are often poorly installed, such as on this pilot boat. After the USO, I mentioned that the MAIB commissioned a technical study of reflectors available in the market, which came up with the horrifying conclusion that none of them actually met the requisite ISO performance standard. The device that performed best was the active radar reflector, which is now available. This met most requirements of the ISO standard, but currently they only perform at X-band, and they require a power supply, which may be a problem. The best type of passive radar reflector available is the type fitted to this vessel here,